Hello and welcome to PreCalc. Today is Thursday, October the 8th, and our topic for today is interval notation and domain restrictions. So it's a review of our two rules that we learned about domain earlier in the week, and we're going to hit interval notation a little bit harder today. So let's dive into it. Make sure that you are pausing and always writing the original problem. Okay, so we want to take this inequality and express it on a number line and as interval notation. Reminder that these symbols are brackets in interval notation, and these inequality symbols are parentheses, and they mean the same thing: do include and don't include. So x is greater than or equal to 4. 1, 2, 3, 4. We include 4, and we want everything from 4 onward. So if it's every possible number greater than 4, it goes a million, a billion, a trillion, all the way up to infinity. So we have 4 to infinity. Okay, let's look at the next one. X is less than 6. Okay, I'm just going to put one tick mark, label it 6. It does not include the 6, so we have an open circle. We know we'll be using parentheses. And it's everything less than 6. So what's the smallest number we can think of? Negative a billion, negative a trillion, negative infinity. And our intervals always read left to right, just like you're reading a book. So our leftmost number is negative infinity, and we're going, and then we stop right at 6, and we don't include 6. Okay, let's look at some number lines that are provided for us and turn these into interval notation. As always, make sure that you are pausing and writing the original problems. So it goes all the way out here, so small that it's negative infinity, and it's going, and it stops at 5. So I have negative infinity up until 5. Parentheses do not include the 5. Okay, on this one, we kind of have two things going on. So let's analyze it. I've got negative infinity all the way to the left up until 4. And then we don't want any of this. And then it picks back up at positive 4 and keeps going all the way to infinity. So I'm going to have two different intervals here. My first one is negative infinity up into negative 4, do not include. To join two intervals, we do a capital U. The U stands for union. It allows us to join two intervals. And then my second interval is from 4, do not include, use parentheses, up until positive infinity. That's my final answer here. Okay, let's take this interval notation and apply it to some problems. Okay, the instructions on all these problems are state the domain in interval notation. Will be the instructions for the next 3 examples. Make sure that you pause and write the original problem. We'll call this example 1. Okay, remember our two rules. Rule number 1, we can't have 0 in the denominator. Rule number 2, we can't have a negative under a square root. There's no square root here, so we don't worry about that. We do have a denominator, so let's find out what makes this 0. going to have to factor this one. If you're still struggling with factoring, please reach out to me as soon as possible so that we can set up a time to tutor and practice. So I get that x is positive 3 and negative 2. Remember, we get that by setting those to 0. And really, its x cannot be positive 3 or negative 2, because if I plug these numbers in, it will make this whole highlighted part 0. Then the denominator would be 0 and the function would be undefined. So it can't be 3, it can't be negative 2, but it could literally be any other number. No other number is going to break the function, is going to make it undefined. So we're going to check this out on a number line. Here's 0, negative 1, negative 2. You're going to put a hole because it's undefined at negative 2. And 1, 2, 3 also has a hole. But every other number works. So all negative numbers this way, everything in between, and everything in this direction as well. So this is negative infinity, it's negative 2, 3, and positive infinity. So I have from negative infinity to 2, then I include all of this, union, negative 2 to 3, and then we skip 3, and everything after 3 we also include. So this is our final answer. Okay, let's look at another example. Great, we have a square root. This is our second case, our rule number 2. There's no denominator here, so nothing to worry about that. I just need whatever's under the square root to not be negative. To make it not be negative, we're going to say greater than or equal to 0. Now we solve. Add 6. Divide 3. X is greater than or equal to 2. Okay, let's look at this on a number line. There's 0. So it includes 2 and everything after 2 all the way up until infinity. So I've bracket because we do include 2 up until infinity is our final answer. Okay, one last example. This is the third possibility when you have a denominator and a square root. Let's do denominator first. It does not matter what you do first. We know this cannot be 0. X cannot be positive 2. Because if I plug that in here, I'm going to get 2 minus 2 is 0. Then the denominator would be 0. So let's pause and actually put this guy on a number line. Here's 0, 1, 2. It cannot be 2, big hole. We don't know what's going on with everything else yet. So let's analyze the square root. We know the square root cannot be 0. Cannot be negative. Square roots cannot be negative. So we're going to set them greater than or equal to 0. We solve this. X is greater than or equal to negative 3. Okay, there's our second piece. Negative 1, negative 2, negative 3. It includes negative 3 and everything after negative 3. So great, we're going. We got to stop because we can't have 2, but still everything else after negative 3 works. So we keep going all the way to positive infinity. So our final answer is include negative 3 to 2, parentheses to not include, union 2 to infinity. That's everything for today, guys. Thanks.